are the members, who are the members of quadrilaterals family tree. Just like you, in your family tree, your parents will be there, your grandparents will be there, you will be there, your sibling, if any sibling is there, that they will also be there in your family tree. You will paste the picture of each and every person, and you will just write the name and what's your relation with that person, that also you will be writing. That way it's just a fun while doing like maybe for practical or any activity, you must have created your own family tree. This is our quadrilaterals family tree. Here, as you can see, the first member of this family is quadrilateral. Okay, so the way how we say in daily life that a person looks like his or her parents, there is a like the features are like his parents or her parents. The way of speaking is also like a any of the parents. So what we do, how we human, how this human things work, that we take the quality of our parents, we take the qualities of our grandparents, just like that. Similarly, here the first member or the eldest member of this family tree is quadrilateral. So each and every family member, that is trapezium, parallelogram, kite, isosceles trapezoid, rectangle, rhombus, square, these all will take the quality of quadrilateral. Whatever is valid for quadrilateral, whatever formula, whatever property, whatever rule is applicable for this quadrilateral, that will be surely applicable for each and every member of this family tree. In human being, maybe we are having the quality of, maybe I am having the quality of my grandparent, my paternal grandparent, or maybe maternal grandparent, that is not sure. But here in mathematics we have, it is certain that each and every other member of the family will be carrying forward the quality of quadrilateral. So as I am saying, quadrilateral is a four-sided polygon, a polygon having four sides. That means a polygon having four sides. Each and every other member, as you can see, are having four sides. Now what else is the property of quadrilateral? That sum of each interior angle is of 90 degree. So this angle, this angle, this angle, this angle, all the sum of all the angle, if this is a quadrilateral ABCD, then sum of angle A, angle B, angle C, and angle D will be 360 degree. And this is not only applicable for this quadrilateral, it is applicable for each and every other member. Okay, these are just the kids of the quadrilateral. If you are understanding that way also you can take it. Okay, so the first thing first is sum of interior angle, sum of all the interior angle of a quadrilateral is of 360 degree. So we are saying that if we are having a quadrilateral, that means a four-sided polygon having name, let's say ABCD, then sum of angle A, angle B, angle C, and angle D is 360 degree. How we will be, how, if this theorem we have to prove it, that prove that sum of all the interior angle of a quadrilateral is of 360 degree, how we will prove this? So if this is a theorem, how we will prove this theorem? So let's prove it quickly, then we will again be getting back to our family tree. So if we have to prove this theorem, then we can divide our quadrilateral in triangles. So if we will be drawing the triangle, if we will be drawing the diagonal BD or maybe diagonal AC, that way you will be able to divide this quadrilateral in two triangles. So if I am drawing a diagonal BD like this, here you can see two triangles. Now I am saying sum of interior angle of this triangle is 180 degree. I am saying sum of interior angle of this triangle is also 180 degree, because we already know angle sum property of a triangle. By using this theorem, we can say sum of all the interior angle of this quadrilateral is 360 degree. And if we have to write that, how we will be writing it? So Here, if we have to prove that, how we will be proving it? We will be saying in triangle ABD, as we can see, angle BAD plus angle ABD, you must know how to write the angle. Angle BAD means angle A. Angle ABD means angle B in triangle ABD plus angle ADB is equals to 180 degree. From where I am writing this? Angle sum property of a triangle says that sum of all the interior angle of any triangle has to be 180 degree. If it is more than 180, less than 180, then constructing the triangle is not possible with such data. Okay. So angle sum property of triangle. Now the next one, this is equation number 1. Now the next one is angle. If we'll be taking angle, other triangle, that is triangle BCD. So BCD, can you see the other triangle BCD? BCD or DBC or whatever name you wanna give it. I'm talking about this next triangle. So here also we can say angle B, that means CBD, plus angle C, that means angle BCD, plus angle D, that means angle BDC. If you are not getting how I am writing the angle, here angle B I am representing, here angle C I am representing, here I am representing angle D. Sum of all the interior angle of this triangle has to be 180 degree, again from angle sum property of a triangle. And once we will be adding equation 1 and equation 2, we will be getting sum of all the interior angle of this quadrilateral will be 360 degree. Okay, so by adding 1 and 2, we can say angle A, angle B, angle C, angle D all together will be 360 degree. From where we are saying 360 degree, we are just adding right hand side with right hand side, left hand side with left hand side. If you understand the figure, then you can see this angle we have taken, this angle, then this angle. We have added all of them by taking the two triangles. Okay, so this way we will, this angle, this orange angle and this orange angle, all the three orange angles I have added with all these three green angles, and at the end we are saying the sum of all the interior angle of this quadrilateral will be 360 degree. Whenever you are cutting a quadrilateral in two part by drawing a diagonal, by taking a triangle, this method is called triangulation. So whenever we are taking the help of, whenever we are having a quadrilateral and we are trying to take the help of triangle, like when you are having a quadrilateral and when you are cutting it in two part by taking one of the triangle, another triangle. So this process of cutting into triangle is called just triangulation. Here this concept will not be there in your maybe the question paper, but you should know this word, that this is called triangulation, to cut a quadrilateral in two triangles. Okay, so from here, this is the theorem how we will prove that sum of all the interior angle of a quadrilateral will be of 360 degree. Now let's get back to our family tree. So family tree says the quadrilateral is having the quality, or the quadrilateral is having the property, that sum of all the interior angle of this quadrilateral will be 360 degree. Now this quality or this property, the quadrilateral will pass on to each and every member of this family tree. Trapezoid, parallelogram, kite, isosceles trapezoid, rectangle, rhombus, square, each and every quadrilateral over here, each and every polygon over here will be, it's a quadrilateral at first, and its sum of all the interior angle has to be 360 degree for each and every one. Okay, now let's move to the first member of the next generation, first member, that is trapezoid, also known as trapezium. So let's discuss about trapezium's property. So trapezium looks like this one. Here, let me draw properly. This is how trapezium looks like. Suppose this is a trapezium PQRS. So here there will be one pair of parallel side. So here you can see PQ is parallel to RS, and the other pair, that means PS and QR are not parallel. The parallel side are known as bases of the trapezium, and non-parallel sides are known as legs of the trapezium. So PS is not parallel to QR, and there is one pair of parallel side. Those pair of parallel side are having a specific name called basis of the trapezium. Whenever it's written in the question, whenever it's written in the theorem that basis of the trapezium is this and that, so you must understand it's talking about the parallel sides. Okay, now you have already learned the concept of interior angle on the same side, alternate interior angle, about parallel, two parallel line and a transversal line concept you have already learned. So if I am saying here there is a pair of parallel line, if I am saying that this PQ is parallel to SR, then you can see this PS works as a transversal over here. Let me mark it. Then you can see this PS works as a transversal over here. All right. So parallel sides are there. PQ and RS are parallel side that we already know it exists in a trapezium, and PS looks like a transversal. Now can we say that sum of this angle and this angle will be 180 degree? Anyone please tell me which property I am applying here and telling that sum of angle P and angle S will be 180 degree. Why it will be 180 degree?
Can you repeat?
Any, yeah.
No, I just asked, can you repeat?
Yeah, I am saying that if PQ and RS are parallel line and PS is a transversal, two parallel line, and there is a transversal like this. So I am saying this angle and this angle will be 180 degree. The sum of this two angle will be 180 degree.
Corresponding angles are 180? No, in, interior angles, the sum of interior angles on the same side of the trapezium are equals to 180.
Exactly. Sum of interior angle on the same side has to be 180, or so few people call it co-interior angle also. So whatever you are saying, either you are saying sum of interior angle on the same side or you are saying co-interior angle, it's the same thing. That's why angle P plus angle S will be 180 degree. Is it clear to everyone?
Yes, ma'am.
Similarly, here angle Q and angle R, sum will also be 180 degree. So angle P plus angle S will be 180 degree. And similarly for this trapezium, angle Q plus angle R will also be 180 degree, because that two are also a pair of like interior angle on the same side of transversal. So this is the property of trapezium. There is a pair of parallel side, there is a pair of non-parallel side. Due to the pair of parallel side, few more extra information, extra properties we are getting, that is the sum of interior angle on the same side is equals to 180 degree. Now whatever is applicable for this trapezium, it will pass on to isosceles trapezium also. So now this isosceles trapezium will having is going to have all the property of quadrilateral and trapezium. Are you understanding how this family tree is going on?
Yes, ma'am.
So now let's discuss about isosceles trapezium. Then we will be moving to the next member of the first generation. Let's finish the branch, one of the branch, that is trapezium, and then isosceles trapezium. Now, isosceles trapezium is just one of the trapezium at first. Here, there must be a pair of parallel sides. So again, if this is, let's say, M and O, P. So there must be a pair of parallel side and there must be a pair of non-parallel side. So here MN is parallel to PO, as you can see in the figure itself. Okay. And NP is not parallel with NO. These two are not parallel with each other. These two are not parallel with each other. And just like the trapezium, we are having MN parallel to PO. Just like the trapezium, here also angle M plus angle P has to be 180-degree, because trapezium has passed on all his quality to the next generation. So angle M plus angle P will be 180 degrees. Similarly, angle N plus angle O will be of 180 degree. This all we got from the trapezium. This all isosceles trapezium has got from its grandparent, or like parent, obviously not grandparent, from its parent, that is, these are the property of the trapezium. Now, what is the extra property of isosceles trapezium? So, as the name says, isosceles. Isosceles means isosceles triangle is having two equal side. So here also there must be two equal side, or something two equal has to be there, because the name is saying isosceles. We have seen isosceles means isosceles triangle where two sides were same. Here isosceles trapezium means here also two sides will be same. Here non-parallel side will be equals to each other. So non-parallel sides are MP and NO, and these two will be equals to each other. That's what the property of isosceles trapezium says. That bases are parallel, that is okay. But for isosceles trapezium, legs will be same. Getting it? Is it clear so far to everybody?
Yes. Yes, ma'am.
Okay, just a second.
Why is MP equal to MO, NO again? Can you repeat?
Because the name is isosceles trapezium. So there must be two sides same, because in isosceles triangle, in if we are talking about an isosceles triangle, if we are talking about an isosceles triangle, what does it mean? There is a two equal side, right? If this is
Yes.
an isosceles triangle, so side AB will be equals to AC, or maybe any two side will be same over here, right? Similar, right?
Yes.
Similarly, in isosceles trapezium, also two sides are same. Which two side will always be same? The legs will be same. This is the property. This is the quality of isosceles trapezium. Is it coming from any of the theorem or something, like any other property or something? No, it's, this is the quality of isosceles trapezium. So what I'm saying, that in this quadrilateral family tree, like each and every member will pass on its property, its quality to the next member. But apart from that, next member will also be having their own particular qualities, right?
Yes.
Right. So trapezium, all the property of trapezium is getting followed by isosceles trapezium. But apart from that, isosceles trapezium's legs will be same. So you can understand it this way, that we are having, like I am having all the property of my mama, but apart from that I also like a few extra, I'm also having few extra hobbies, which is my quality. So everything I have taken, but I am having my own qualities as well, right?
Yes.
So similarly, this isosceles trapezium is having all the property of quadrilateral also and trapezium also. But apart from that, it's also having its own particular quality. And that quality says, since the name is isosceles, Two side will be same. Which two side will be same? The legs will be same. Okay, this is the property of this isosceles trapezium, which we have to keep in mind. Maybe when we are solving the question or when we are dealing with the theorem, whenever the word isosceles trapezium will come, we must know that leg of the isosceles trapezium are equal and we must take the leg same. Okay, is it okay?
Yes.
Now let's move to the next member of the first generation. So the next member of the first generation now is parallelogram. Parallelogram will take the property of quadrilateral, obviously. Is parallelogram is a quadrilateral? Yes, it's a quadrilateral. Is trapezium is a quadrilateral? Yes, it's a quadrilateral at first, and then it's having its own property, having certain few more qualities, and the name is trapezium. Okay, so in future, whenever the fill in the blanks will be there, that is rectangle a parallelogram? Yes, rectangle is a parallelogram. Is rhombus a parallelogram? Yes, rhombus is a parallelogram. Is a square a parallelogram? Yes, a square is a parallelogram. Can you see? First,
Yes.
it's a parallelogram and then it is having its own name, that is a square. Is a square a rectangle? Yes, a square is a special case of rectangle only. Why? In rectangle, like there is a length and there is a breadth, but in a square, those length and breadth are same. So square is a special kind of rectangle only. Previously, you must have you if you have seen such sentences anywhere, then there is a possibility that you will you must have got confused over there, that why it is saying that rhombus is a parallelogram, why it is saying rectangle is a parallelogram. These are different shapes. Yes, these are different shapes, but first we have to take the like elder one's property first it will be taking, then it is having its own identity. Parallelogram is first a quadrilateral and then it is having its own identity, that is parallelogram. Getting it? So let's discuss about parallelogram in detail. So parallelogram, as we know, suppose we are having, what is the property of parallelogram? The property of parallelogram says that if ABCD is a parallelogram, then its opposite side will be parallel and will be equals to each other. So here AB is parallel to CD and AD is parallel to BC. Opposite sides are parallel and also opposite sides are equals to each other. That is the quality, that is the property of parallelogram. Where
Parallel sides.
opposite side, yeah, yeah,
Okay. No, I
yeah,
just asked if parallel sides are equal.
yeah, what?
I just asked whether parallel sides are equal.
Yeah,
Yes.
yes, parallel sides are equal also for parallelogram. Okay, apart from that, here angle A will be equals to angle C and angle B will be equals to angle D. That is also the property of parallelogram. So angle A is equal, opposite angles are also same in a parallelogram. Angle B is equals to angle D over here. These are the properties of parallelogram. Now one more thing you can apply here, since I am saying that this and this are parallel. Again, this is a transversal. So we can say here that angle A plus angle D is equals to 180 degree. From where are we getting this? This we are getting from its quality. That is parallel side is there, then sum of interior angle on the same side has to be 180 degree. Similarly, angle B plus angle C has to be 180 degree. But here we are having both the pair of parallel line. Like AB is parallel to CD. AD is parallel to BC. Two pairs of parallel lines we are having. Not just like the trapezium, only one pair of parallel line we don't have over here. We are having two pair of parallel line. The red lines are parallel. Let me show you. This sky is parallel to this sky, and this green is parallel to this green. So since here the greens are also parallel with each other, so what we will be getting? We will be getting two more condition. Though these two green lines are parallel with each other, so we can say this angle and this angle sum will also be 180-degree, right? Those
Yes,
two
ma'am.
are also interior angle on the same side of transversal. So angle A and angle B will also be 180-degree. Similarly, angle C and angle D will also be 180-degree. So in trapezium, we were having only one pair of parallel line. The upper one and the lower one was parallel. So we were getting two condition in the trapezium. But here, since it's a parallelogram, we are having two pairs of parallel line. The horizontal line on the top, horizontal line on the bottom, both are parallel. So here, from here we are getting two condition, and the vertical lines are also parallel. So from here also we are getting two condition.
Ma'am, why is equal to angle A equal to angle C?
Here this is there is a like we will be proving it why it's same with the help of the theorem that prove that in a parallelogram opposite angles are same. There we will be using the concept of congruency and all. This are in the theorem which we will be proving just after a while. So
Okay, ma'am.
there is no like proper one definition is not there which will justify it that A is equals to C, B is equals to D. There is a proper method to prove it that yes, opposite angles are same. That method we will be discussing just after a while. Okay.
Okay, ma'am.
Now, for now, what are we discussing then? We are just taking the we are just learning the qualities as it is, and after a while we will be proving few qualities. Okay.
Okay, ma'am.
Okay, let's see what is the next generation of parallelogram. So the next generation of parallelogram is rectangle. Is rectangle a quadrilateral? Yes, rectangle is first a quadrilateral, then its name is rectangle. Is rectangle a parallelogram? Yes, rectangle is a parallelogram, and then having its own quality, having its own particular name, that is rectangle. So does rectangle follow all the property of parallelogram?
Ma'am, I
Yes.
have doubt.
Yeah, please
So in
ask.
MCQ, they will be asking like, which of the following is a rectangle? Like, first they'll give options quadrilateral, then parallelogram. So which is first? Which should I choose first?
uh, uh, if only one will be there, either parallelogram will be there or quadrilateral will be there, because rectangle is also a quadrilateral, rectangle is also a parallelogram. So this way option will not be there that it is a quadrilateral or it is a parallelogram, because it is both. Okay.
Yes, ma'am.
Now, if it is asking is rectangle, option can be like this. Rectangle is a trapezium, rectangle is a parallelogram, rectangle is a kite. This way option can be there that rectangle is is it a trapezium, is it a parallelogram, is it a kite. So that way options are there, then you will be saying it's a parallelogram. Okay, according to this branch. But rectangle are dash and dash, that means rectangle is a parallelogram also and rectangle is a quadrilateral also. Quadrilateral means a polygon having four sides. We can see rectangle is having four sides. And yes, it's a parallelogram also, because it is going to follow all the property of parallelogram. So it's a parallelogram also. Okay, so when the option will be given, it will be given in such a way that you will be able to understand that which option is the correct option. Two same family like sequence will not be given. All right, let's move to rectangle. Is it clear? Yeah. Is it clear that how the options will be given?
Yes, ma'am.
Okay. Now let's move to the next rectangle. So as I am saying that it's a rectangle ABCD, and it's just like a kid of parallelogram. So it will follow all the property of parallelogram at first. What was the property of parallelogram? AB is parallel to CD and AB is equals to CD. AD is parallel to BC and AD is equals to BC. We know these are the property of rectangle also, that opposite sides are equal. From where it came this, from where this qualities came, that this is equals to this and this is equals to this, from where this quality rectangle has got, from the parallelogram only. Now, whatever is the remaining property of parallelogram, each and every property is applicable for this rectangle also. That means angle A, angle C, opposite angle will be equal. Angle B, angle D, opposite angle will be equal. Here, angle, what else we have listed down? We have listed down angle for the parallelogram. Angle A plus angle D is equals to 180. Angle B plus angle C is equals to 180. Angle A and angle B is also 180, because these two sides are also parallel and transversal we are getting in the parallelogram. Till now what I am writing all the qualities of parallelogram, and I am again repeating that this property is going to, like, rectangle is going to have all this property in the first place, and then rectangle will be having its own particular property. Okay. So angle C plus angle D is equals to 180. These are the properties of parallelogram which rectangle will also follow. Now the property of rectangle is each interior angle of rectangle is of 90 degree. This was not the property for the parallelogram. This is the specific property of rectangle, that here for rectangle it is having some extra qualities, and that extra quality is each interior angle of the rectangle will be of 90 degree. Okay. Just a second. Yeah. So these are the properties of rectangle. Now let's see who is the next member of that sequence. Parallelogram, then rectangle, then rhombus is also there. So now we are going to discuss about rhombus. Is it clear so far to everybody?
Yes, ma'am.
Rhombus. Now as you can see in the picture, rhombus is also, in the first place, rhombus is a parallelogram. And then rhombus will be having its own particular qualities or properties. So rhombus is a quadrilateral, or we can draw rhombus like this also. Like this also. What basically what we are trying to say, that it is having all the properties of parallelogram. Here A, B, C, D, opposite sides are parallel, opposite sides are equal, opposite angle are same, and the consecutive angle sum will be 180 degree. Everything it is going to follow from as the according to the property of parallelogram at first. Now rhombus is having its own particular property. That means all sides of a rhombus are of same length. One more property rhombus is having. Okay, here AB is equals to BC is equals to CD is equals to DA. This is the specific property of the rhombus. Now, one thing I have not said over here, that is, in a parallelogram, the diagonal bisect each other. The diagonal will bisect each other. If you are having a parallelogram like this, ABCD, here the diagonals will bisect each other. That means both the diagonal is cutting each other in equal part. Here the diagonal AC, that means AO will be equals to OC. And the diagonal BD, that means BO will be equals to OD. That also we will prove just after discussing this family tree, that why AO, OC, BO, OD, this will be equal, that we are going to discuss. So diagonal of a parallelogram bisect each other. Both the diagonal will cut each other in equal part. Okay. So that is also the property of parallelogram. Now that means that is also going to, like, rectangle will also follow this property of the parallelogram. That means diagonal bisect each other. Okay. And rhombus is also a parallelogram in the first place. So rhombus will also follow this property, that diagonal of this parallelogram or quadrilateral or rhombus, you say, will bisect each other. That means AO will be equals to OC and BO will be equals to OD. This is the quality of parallelogram, which parallelogram has passed on to rectangle and rhombus. Okay, apart from that, we were talking about rhombus in detail. What is the specific property of the rhombus? So specific property of the rhombus is all side of the rhombus are of same length. Apart from that, there is one more quality of the rhombus which says that diagonal of rhombus bisect each other at right angle. So diagonal of a rhombus bisect each other. It came from the parallelogram only. But at right angle, this is the specific property of the rhombus. Okay. So diagonal of a rhombus bisect each other at right angle. Here each and every angle, this angle will be 90 degree. This angle will be 90 degree. This angle will be 90 degree. And this angle will also be 90 degree. This is the specific property of rhombus. All right. Now let's move to the, is it clear so far to everyone?
Yes, ma'am.
Now let's move to the next member of this same sequence. As you can see the sequence, parallelogram is having the subpart as a rectangle, another subpart is rhombus. Now this rectangle and rhombus is having the subpart as a square. Okay, now I'm going to say this square will carry on all the property of quadrilateral, parallelogram, rectangle and rhombus. Okay, so as you know, square is having all sides same. From where it came? It came from the rhombus. A square is having each interior angle as a 90 degree. From where it came? It came from the rectangle. Getting it?
Yes.
Are you getting? So square is going to follow all the property of each and every previous member. Okay, now we are left with kite. Now this kite is quite different from other member of this family. Let's draw the kite. So basically kite will look like a real life kite only, and from there only this shape came out. Here we will be having two pair of parallel, not parallel, here no parallel sides are there. Here we will be having adjacent side of the kite. This side PQ and this PS, these two sides are same. same length I'm saying. Okay, and similarly side QR and side RS will be of same length. So there will be two pair of side which will be equal with each other in a kite. Okay, here longer diagonal of the kite bisect the smaller diagonal. What does that mean? Both the diagonal are bisecting each other? No. Both the diagonal are not going to cut each other in equal part. Here, the longer diagonal is cutting the smaller diagonal only in equal part. That means only smaller diagonal is getting cutted in two equal part. Here you can see QS is the smaller diagonal, so QO is equals to OS. But the other one, OP and OR, is it equal in a kite? No. Longer diagonal are not getting bisected. Only the smaller diagonal are getting bisected in a kite. Okay. One more property is there for kite, that the angle between non-equal side are, as you can see, PQ and QR are non-equal side, right? These two greens, this green and this green, these two are non-equal side, right? So angle between non-equal side of a kite, this angle, and other two non-equal side, this is sky and this is sky, are non-equal, not equal with each other. So angle between these two non-equal and angle between these two non-equal, these two angle in a kite are same. So what's the total property of a kite? That there are two pair of adjacent side which are same in length. That is the first property. The second property says the longer diagonal of a kite bisect the smaller diagonal. What does that mean? The smaller diagonal is only getting cutted in equal part. And the next property is the angle between non-equal side, the two sides which are not equal, angle between that side and two sides which are not equal, angle between other uh, those two sides, these two angle are of same measurement. Here angle Q is equals to angle S. This is the property of kite. Don't worry, kite will, like, very rarely you will see kite in this chapter. Like, there is no question related to kite, but you should know the property of, like, at least the property of, for this chapter, the property of parallelogram, rhombus, rectangle, square. These are very important. This parallelogram family, these are very important for this chapter. You must understand very well the properties of parallelogram and the remaining also. Like, first thing first, you should keep in mind what are the properties of parallelogram, what are the properties of rectangle, rhombus and square. Quadrilateral is having just one quality, that is four-sided polygon is called quadrilateral, and sum of interior angle of quadrilateral is 360 degree. That is applicable for all the other members. Okay, now we are going to start with parallelogram. Basically, as I am saying, this is the main part of this chapter. This family tree, you can note it down in your notebook, you can write it anywhere, you can keep it anywhere, so that whenever you will be having the fill in the blanks, and whenever in future somebody will say that is rhombus or quadrilateral, you will not get confused. Quadrilateral is a different shape, rhombus is a different shape. Yes, rhombus is a quadrilateral. Okay, so this family tree will help you to solve the to attempt the question, like 1 mark question, from true false, from the fill in the blanks, from the MCQ question, just like that. You must have the knowledge of these. Then now we are going to start with the theorem which you were asking, Arya, that why these are same, why these are not same. How can we saying, like, how are we saying directly that these two opposite angles are same, or any other property? So we will be proving it one by one. Okay, it's already 27. Let me take one theorem and let me see whether it's possible to start today or not.